how the universe began, how it's going to end, and how it works. All questions that science struggles to provide a hard and fast answer for.
Any kind of black hole that could pass through the solar system would be pulling on all the planets harder than the sun does.
The violence of this is hard to imagine. Two planets coming together. The formation of stars as
After an impact of that scale, the entire surface of the Earth is literally liquefied.
Theories are ever changing, and as we strive to unlock the secrets of the universe, we're met with more questions than answers. So what are some less widely accepted theories about the universe that just make sense? Welcome to Factnominal. Today, we're separating fact, fiction, and conspiracy theory in universe theories that just make sense. Number 10. Brain world. No, we don't mean brain as in the thing between your ears. We're talking about the clash of membranes. And although it sounds like a bizarre concept, it actually has some merit. The brain world concept pictures our universe as a membrane floating in a higher dimensional space, repeatedly smashing into a neighboring membrane universe. Though gravity can reach out between membranes, our existence is confined to the three dimensions of our own universe. According to this idea, the Big Bang could have been caused by one of these impacts between two membranes. More to the point, if it's happened once, it's likely to happen again, pointing to the possibility that there are multiple and never-ending Big Bang-level events, an immortal cosmos caught in an infinite cycle. Number 9. The Big Splat. In the very distant future, the rapid expansion of the universe will accelerate to the point where galaxies will move so far adrift from each other that the light from Galaxy A will be unable to reach Galaxy B. The expansion rate would exceed the speed light travels. Eventually, there will be no more raw materials for the birth of new stars, and those that already exist will burn out and die, creating a universe devoid of light and heat. It may sound all gloom and doom, but it doesn't need to be. The beginning of a new universe is just a smash between brains. Over time, two empty and spent universe membranes could collide with each other and generate enough energy to stimulate another Big Bang, subsequent rapid expansion, and birth of a new universe. It's referred to in scientific journals as ekpyrotic theory, or more affectionately, the Big Splat. Number 8. The holographic universe. You've heard of living inside a simulation, but how about a holographic universe? Ask anyone what the universe is made of, and they will give you the same answer: matter and energy. But what about information? A ribosome in a human cell is supplied with amino acid building blocks and energy from the mitochondria, but it can't make anything without the blueprint from the cell nucleus. This holographic principle works in the same way when describing the universe. It's a combination of string theory and the unique property of quantum gravity that can describe the volume of space from encoded data on the lower dimensional boundary of the region. Think of space like a hologram, a two-dimensional picture that has the data to create a three-dimensional image. It's a testable theory and is a pattern consistent with cosmic microwave background radiation left over from the Big Bang. Number 7. The steady-state universe. It's widely accepted that the Big Bang was a singularity, a point of near-infinite mass and density from which all the matter and energy in the universe originated, before it rapidly expanded outwards from the central point. Nothing will ever be as dense as the Big Bang singularity, and over time, the density of the universe decreases as it expands through space. But what if there were a way for density to remain constant in this ever-expanding universe? The steady-state universe theory describes the continuous creation of matter as possible at a rate of 3 hydrogen atoms per cubic meter every million years. In theory, the universe has no beginning, no end, and no finite age. Einstein once considered a steady-state model for the universe, but abandoned the idea. It fell out of favor as the commonly accepted theory with the discovery of cosmic microwave background radiation. Number 6. The multiverse. The current working Big Bang model predicted the existence of cosmic microwave background radiation, but it struggles to explain its uniformity. A theorized period of early superfast expansion was needed for it to work, otherwise known as inflation. When our universe ended this inflationary period, it may have been a single small bubble sitting in the vast sea of space. It's possible that other little universe bubbles were also floating in this void. In other words, a multiverse of universes. As expansion slowed following inflation, the laws of physics in our universe stabilized. but it's entirely possible that in other universes our laws don't apply. Their force of gravity may be stronger, they may have a faster speed of light. There is a cold spot in the cosmic microwave background radiation that could be evidence of a collision with a neighboring universe within the multiverse. Number 5. The evolving universe. The gravity of a black hole compresses matter into a single focal point, a place that exists outside of the dimensions of time, space, and reality. What if this dense focal point bounced back and made a new baby universe? The offspring made by black holes may have differing laws of physics from their parent universe and would in a way evolve from them. If, and that's if, we live in a typical universe and have physical laws of physics and mathematical constants that favor production of black holes, then perhaps ours would be one of the more dominant ones in the multiverse. By the same theory, our universe would exist within the black hole of another. Number 4. The Goldilocks universe. What constitutes a universe that has the ability to support life? Certainly ours does, or we wouldn't be here to observe it. The fact that we exist, that we know we exist in this particular universe, strongly indicates that we can assume our universe has the correct parameters for life to not only exist, but thrive. By mildly modifying some universal constants, the formation of stars and matter becomes an impossibility. The universe collapses within the blink of an eye. String theory hints at the fact that the universe has almost infinite number of different properties and laws that could combine in any way. Inflation points to the possibility of infinite universes, so theoretically ours could be the only one, or one of very few, with the ability to sustain matter and therefore life. Everything in just the right amounts. Number 3. The Ghost Condensate. Something unknown is ripping apart space-time. Something unknown is holding galaxies together. Something unknown made the cosmos go bang at the beginning of time. These unknowns are dark energy, dark matter, and inflation. But what if they are all the same thing? A single change to Einstein's law of gravity and general relativity could account for this trio of unexplained and undetectable phenomena. The result is a weird, omnipresent, all-pervading fluid of massless particles called the Ghost Condensate. These exhibit repulsive gravity, like an elastic band that stores more and more energy as it stretches further apart. If you think of it this way, it kind of does explain how dark energy pushes space apart, how dark matter holds galaxies together, and the rapid inflation immediately after the Big Bang. Number 2. Superfluid space-time. Everything in space spins in relation to each other's gravity: stars, planets, galaxies, and clusters. Yet research points to the fact that the universe itself is not rotating. But why? Maybe space-time flows like an incredibly smooth and free-flowing superfluid. It would resolve the inherent contradictions between two popular and opposing theories. Particles and photons would travel through space-time like waves in an ocean, according to the laws of fluid mechanics and condensed matter physics, losing energy over time as they travel through the superfluid medium. Possibly, photons of different energies travel at different speeds and could even dissipate over time, proving that general relativity doesn't account for all circumstances and that the speed of light is not a universal constant. This would mean matter is just debris adrift in the vast ocean of space. Number 1. Mond gravity. Dark matter may not be matter at all. It could just be an unobserved behavior of gravity. Modified Newtonian dynamics, or MOND, pronounced MOND, suggests that galaxies are not held together by phantom, undetectable stuff at all. That there is a perfectly logical explanation for why the velocities of stars and galaxies are observed to be larger than expected based on regular Newtonian mechanics. Maybe the answer's been found by adding a minimum value for acceleration. Perhaps gravity doesn't fade away as quickly as current theories dictate, and this version of gravity that is stronger and more longer lasting could fill the role thought occupied by dark matter. This alternate form of gravity could be the binding force of galaxies and clusters. The Mond theory is consistent and works within general relativity and has accurately predicted certain phenomena in the universe, stating that the observable universe makes up just 5% of the total stuff contained within it might be an assumption that's as wrong as it sounds.